Assalamu alaikum. So students, in the last lecture we have discussed about Ohm's law and experimental verification of Ohm's law, and in that case we have discussed about a resistance of a conductor. Now our today's topic is combination of resistors. We can combine resistors. How we can combine these resistors? First of all, I will tell you again about a resistor. A resistor is actually a passive two-terminal electrical component. Resistor is actually a passive two-terminal electrical component that implements electrical resistance as a circuit element. I told you already, electrical resistance is the property of a conductor that opposes the flow of electric current. That is why I have written here it is a passive two-terminal electric component that implements electrical resistance. Implements electrical resistance means it opposes the flow of electric current as a circuit element. Now we can use these resistors in different electronic circuits to reduce flow of current. In order to reduce the value of electric current, we can use these resistors in two types of combinations: series combination and parallel combination. Or also we can say, in order to reduce flow of current, or we can say to adjust the signal value and to divide voltages. We can combine these resistors. So in order to divide the voltage, in order to adjust the signal voltage, in order to reduce the value of current, we can combine resistors in two combinations: series combination and parallel combination. But before going thoroughly on series combination, I have shown already the symbolic representation of this resistor is like this. That is why I have written it is a two-terminal device, one terminal here, another terminal here. Two-terminal device. This is the symbolic representation of resistor. Now we are going to discuss about series combination of resistors. As shown in the diagram, I have combined three resistors having respective resistances R1, R2 and R3. First, second and third. Let V be the potential difference applied across the two combinations, across the 2 points A and B. A and B are the 2 points. I have applied a potential difference. So we can see this combination is known as end-to-end combination. It means this is first resistor, another resistor is combined in the same way, along the same line. So we can say resistors are said to be combined in series. But in series combination, when we give a current at point A, that current, suppose current I have given, that current I is flowing through each and every resistor. Current I flows through R1, current I flows through R2, and the same current flows through R3 also. So current flow is same. So we can define a series combination of resistors. In series combination, we can say resistors are said to be combined in series if same current is flowing, through each resistor, but when some potential difference is applied across the combination. Or we can say these resistors are said to be in series if they are connected end to end. It means one resistor, one end of one resistor is connected to another end of resistor. That combination is known as end-to-end combination. For example, this is the second end of first resistor, whose second end is connected to first end of second resistor, whose second end is connected to first end of third resistor, and so on. This combination is also known as end-to-end combination. So when resistors are connected end to end, then the combination is known as series combination. So as shown in the diagram, I have considered three resistors having respective resistance R1, R2 and R3, three resistors, and I have applied between points A and B. I have combined these three resistors, and between these 2 points a potential difference of V voltage. Potential difference V is applied across A and B using simply a battery. But in series combination, I told you same current flows through each and every resistor. Now since we have applied a potential difference, let us consider now V1, V2 and V3 be the potential differences across the resistors R1, R2 and R3. So V1, V2, V3 be the potential differences across resistors R1, R2 and R3. But this potential difference but this potential difference, total potential difference V, it should be equal to V1 plus V2 plus V3. Similarly, if we have 4 resistors, we can say V is equal to V1 plus V2 plus V3 plus V4, so on. If we have 5 resistors, this process continues. Now, as per Ohm's law, we know that as per Ohm's law, V is equal to IR. We have already deduced it, we have already derived the relation, that is V is equal to IR. Now for first resistor, we know that potential difference is V1, current is following I, and resistance is R1. So for first resistor, V1 is equal to R1, V1 is equal to IR1. Similarly, we can see for second resistor, V2 is equal to IR2, and similarly for third resistor, we can see V3 is equal to IR3. So we have calculated the values of potential difference by using simply Ohm's law, which is the relation between V and I. So for first one, V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3. Now we know that these resistors are combined in series. There should be a total resistance. That total resistance is also known as equivalent resistance, or we can say that resistance is also known as effective resistance. Let us denote that total resistance is denoted by RS. R subscript S means total resistance in series combination. Let RS is the equivalent or effective or total resistance of the given series combination. Where we have applied that series combination, we have applied a potential difference of V volt. We have applied a potential difference of V volt. Then we can say as per above. Similarly, we can use again Ohm's law. V is equal to I RS, where RS is the total resistance in series combination. When we can take these values, that is V, V3, V2 and V1, and we are substituting these values in this equation, that is we have given that equation by equation first. So instead of V, we can write I RS is equal to, instead of V1 we can write I R1, instead of V2 we can write I R2, plus instead of V3 we have derived above, we can write IR3, which implies we can say IRS is equal to I, we can take it as common, R1 plus R2 plus R3. So we can, the I, that is current on both sides is same, that gets cancelled, then we get RS is equal to R1 plus R2 plus R3. So in series combination, we have derived the equation, that is RS is equal to R1 plus R2 plus R3. Now we can explain this equation. Now what about RS? RS is known as total. RS is known as total resistance, or I told you it is also known as equivalent resistance. So therefore we can say equivalent resistance must be equal to R1 plus R2 plus R3. We have combined 3 resistors having resistances R1, R2 and R3. So total resistance in series combination is always equal to the sum of individual resistances. For example, we have 3 resistors, R1 having value of 2 ohm, R2 having value of 3 ohm and R3 having value of 4 ohm. Ohm, already told you, it is the unit of resistance. We have to calculate RS. In series combination, these 3 resistors are combined in series. Calculate the equivalent resistance, then RS should be equal to R1 plus R2 plus R3, then which implies RS is equal to R1, it is 2 ohm plus 3 ohm, then it is 4 ohm. So we can say it is equal to 3 plus 2, 5, 5 plus 4, it should be equal to 9 ohm. So 9 ohm will be the total resistance of the series combination. Okay, now what are the important features of this series combination? We also discuss in the same lecture. First of all, most important feature of series combination. In series combination, we have seen that current is same in every resistor. Current flowing through the series combination always remains same, remains constant. Number second feature, current in the circuit is independent upon the relative positions of the resistors in series combination. We have combined 3 resistors, first R1, R2 and R3. If we can combine them in reverse order, first we can take R3, then R2, then R1. There is no effect upon the current. That is why in series combination, current in the circuit is independent upon the relative. If we can change the positions of the resistors, there should be no change in the value of current. Now number third important in future, voltage across any resistor is directly proportional to the resistance of that resistor. It means we have seen that R1, R2, R3 are the respective resistances of the three resistors. When we have already potential difference, that potential difference is divided into three resistors, V1, V2 and V3. So it means this important future, voltage across any resistor is directly proportional to the resistance of that resistor. If the resistance is more will be the potential required for that resistor. Similarly, fourth, total resistance, we have derived the equation total resistance in series combination is equal to the sum of the individual resistors. So we have taken the sum, we have derived the equation Rs is equal to R1 plus R2, as you can see, R1 plus R2 plus R3. So it means total resistance in series combination is equal to the sum of the individual resistors. Now number fifth, total resistance in series combination, सीरीज सर्किट की जो रेजिस्टेंस होती है इज ऑब्वियसली मोर देन द ग्रेटेस्ट, दैट इज लार्जेस्ट रेजिस्टेंस इन द सर्किट. वी हैव टेकन वन न्यूमेरिकल हियर, R1 2 ohm, 3 ohm, R2 and R3 is equal to 4 ohm. So largest resistor is 4 ohm. We have calculated the total resistance, it becomes 9 ohm. So 9 ohm is obviously greater than the 4 ohm. 4 ohm is the largest resistor among the three. So that is why this becomes the total resistance, and this becomes the important future. We can say total resistance in series circuit. Total resistance in series circuit is obviously more than the greatest, that is largest resistance in the circuit. More than that value should be the total resistance of the circuit. Okay.